the fundamental thing that defines biomedical engineering is it enhances healthcare innovation and improves people's quality of life. So we're developing medical technologies and systems from all aspects of dealing with human disease. So all the way from diagnosing a disease to analyzing how the disease is progressing to therapy, so treating the disease, and also rehabilitation. So people who undergo injuries and now need to bring their life back on track. And the development of these technologies requires you to integrate engineering with the life sciences, which I think is really great because that is essentially cross-disciplinary. We're really combining two very completely different fields together to create new and exciting things. And out of this spins medical technologies and health innovations. And there is all these different things that come into like electrical, mechanical, material science, information technology, medical science, and so much more. So in our school here, particularly, we have academics who specialize across all these different areas, and this is not exhaustive at all. So there's medical devices, as I mentioned earlier, and robotics, computational technology and artificial intelligence. There's tissue engineering and regenerative medicine, which is what I work in, so rebuilding or regrowing organs and body parts. There's microfluidics, molecular diagnostics, genomics, bioinformatics, and of course, health innovation, regulation, and economics as well. So scope for you to be able to do pretty much whatever you want. And we've got the technical expertise to be able to support you in that journey. So this is just an overview of all the different streams of engineering that we have. You can see biomedical is one of them. We also have lots of different, like engineering is definitely UTS's strongest faculty, and we've got a very mature set of degree structures around building you to be the future engineers. And we can also come down to, further broaden your skills and experiences. A lot of these engineering degrees can be combined with bachelors in other faculties or other disciplines like arts, in business, creative intelligence, language, medical science, and science. So what can you do when you come out as a biomedical engineer? Well, all of these and so much more. So you can do R&D for new technologies in academic institutions, in universities, obviously also in industry and biotech companies as well. You can work for hospitals and clinics, for instance, supporting clinical trials to test new therapies for patients to try and bring a new medical product forward. You can work obviously for biotechnology manufacturing companies so that we can bring our new technologies to a global manufacturing scale for it to be supplied worldwide. You can work for pharmaceutical companies to develop better drugs, work for research institutes, obviously, and also some of these other things, other areas like working in regulatory affairs, for instance, and also commercializing products. If some of you here are also considering maybe like a medical related degree, like potentially becoming a medical doctor down the track, but you're not sure yet, biomedical engineering is actually a really great choice. And I would say it's better than medical science because it gives you a lot broader kind of career pathways afterwards, but you still have the option to be able to go back and do a medical doctorate degree if you wanted to. I can't recommend it highly enough, but there are so many different options available. So just briefly touching on the course structure. So our engineering degrees are combined with the Diploma professional practice. So that brings you to 5 years in total. And 1 year out of those 5 years is split into 2 semesters where you undertake internships. So this is a 6-month internship and this is another 6-month internship. And you can do that in a lot of different ways. So you can either go go as an intern in a biomedical company. So we have partnerships with lots of different companies, and also you can choose to do them with academics like myself if you're more interested in the research that we do, and also maybe having a look into the teaching side of things, or doing some wet lab work, for instance. And so in the first and second years, or the first 3 semesters, you're going to be doing a lot of your engineering core subjects. So those will be your mathematics, maybe material science, solid mechanics, and like basically just your engineering core subjects. And there's also a separate set of core subjects, which are your biomedical cores. So one of those is a subject that I coordinate, which is called Introduction to Biomedical Engineering. And that sort of just gives you a landscape view of the field of biomedical engineering. So like it's subjects like those that comprise what you do in the first 2 years or 1.5 years. And then in the third and fourth years, then you do some engineering course, biomedical course, and then you also get some choices as well. So you get to choose some electives, and there are also electives here. And it's much more customized, of course, towards the fifth year as well. So yeah, so basically you can see that towards the later part of your degree, because of these flexibility and choices, you get to specialize more in a area of specialization interested in, whether it be maybe medical robotics or working with cells or maybe genomics and bioinformatics. So you can choose to take subjects that inform your interest better in a particular area within biomedical engineering. And there is also, I just wanted to note also here that for the elective subjects, I guess depending on how the border goes, this potentially could be a study exchange semester overseas. So definitely get in touch. By the time that you guys get to that stage, I'm hoping that we'll be more back to normal in terms of international travel. So with biomedical engineering, we can combine, we have the option to combine them with these different bachelors, so Bachelor of Business, Bachelor of Science, and Bachelor of Creative Intelligence and Innovation. So that'll just expand your nature of the subjects that you do a bit more. And also, I think that also changes your degree structure. So your combined degree then also spans over 5 years, but you have the choice to not do this diploma of professional practice. So your degree over 5 years ends up with 2 bachelor's degrees, and you can also choose to still do this diploma, but that will be an extra year, so 6 years. Whereas the 2 bachelor's degrees combined course subjects will all be spread over the 5 years. Just to, I guess, finish up on the last couple of slides, particularly towards the later years of your degree, this is really exciting. Like we have lots of different studio subjects whereby students spend the majority of their time in the lab doing individual group projects, and they can be on like all different aspects of biomedical engineering. So you can see there are some that are designing prototypes, there are people who are doing some electronics, and also people who are doing, this looks like some cell-based work as well. So there's lots of different studio subjects where you get hands-on experience into doing engineering projects, and you have like, you know, things coming out of it that are really exciting to report on. And sort of tied with this, but differently, because capstones are individual projects, these are 12 months hands-on research projects that you undertake with an academic within the school. And at biomedical engineering, we have more than 20, probably almost 30 now, different academics and research teams that they lead, overall leading to over 100 different projects in all these different areas. So you can definitely pick a project that spikes your interest. There's things in robotics and 3D bioprinting and personalized medicine, microfluidics, engineering cells, tissue engineering and regenerative medicine. There's biomaterials and medical implants. There's a big chunk on cancer research and diagnostics, and also working on the nano level, so nanomedicine, biosensors, and much, much more. So you get to, with the help of an academic, shape a project that you're interested in, do the literature search and critical analysis around the gap in the field, and then you go and design and implement and test your own unique solution to this problem, and then write up a research project around it. It's really highly interesting. Our capstone students find this a really enriching experience. I think this is my last slide. So just covering a little bit more on the diploma in professional practice. So as we said earlier, it's 2 6-month internships. One you take around 2nd year and the other one around 4th year. So usually people take it in the 2nd semester of 2nd year and 4th year, but that's not the only time that you can take it. So it's a little bit flexible. You get the opportunity to get real industry and or academic experience before you even graduate. And that is really highly valued by your future potential employers. And you develop a wide range of professional engineering skills. And I guess most importantly, you start building up networks with top organizations and employers in the engineering sector before you even graduate. And I think this is one of our core values at UTS, and one of our greatest advantages in that we equip our future graduate engineers with the best possible professional skills and experience for them to become the engineers of tomorrow and be highly valued by our society and sector. So I think That is all from me, and I will hand over to Pranitha, who is doing her current Bachelor of Biomedical Engineering and also happened to intern with me for a short period of time just not long ago. So I'll hand over to you, Pranitha.
Thanks, JJ. Hi, everyone. I'm Pranitha, and I'm currently in my final year of studying biomedical engineering and business. I've always been interested in STEM and applying medical technology to improve quality of life. I really believe that this field is the future and it's always evolving, and that's the main reason why I chose to study this degree. As JJ mentioned, I am currently working with her on an internship. On a tissue engineering internship, mainly focusing on osseointegrated implants. So I'm currently writing a review paper as well. And yeah, it's been a great experience so far. UTS has so many opportunities to enhance student life and great opportunities for women in engineering as well. So if anyone has questions about societies, internships, or extracurriculars, please feel free to reach out.
I am going to be talking about a few of the little things to get into this course. So ATAR, adjustment points for UAC. Points are added to a student's raw ATAR to give a selection rank. Adjustment points are capped at 13 at UTS. Adjustment points can be given for a number of factors, including completing the UTS Engineering IT questionnaire, good results in relevant HSC subjects, gender and special circumstances, and more. So the UAC Key Dates, if you guys haven't researched on anything with scholarships, you guys should do it now. It's from April to June. I always suggest just applying, even though you guys might not think you're eligible and everything, just do it. We have open day on the 27th of August. Then there's the HSC exams. The scholarships offers will be released in December. The ATAR results will be released on December 15th. And then I think there's another round that goes around after, which will be around in December and January, February, I think. And then UTS orientation will be in February. And then the autumn session starts in March. We use year 11 results to enter UTS. So pretty much you're eligible if you're a current domestic or international onshore year 12 student. You apply through the UTS online application portal, so not UAC. It is free to apply and applications open around June to July and close in September. So yeah, we haven't got all the dates yet, but if you look at the website and check for updates, it'll be there. Provisional offers will be released on October before the HSC commences, and you must complete the HSC or equivalent. I know from engineering, doing engineering, a lot of people have a lot of questions about what if I didn't do extension maths or I didn't do physics and chem. So we have these bridging courses offered, which is for maths, physics, and chem. You do them right before, it's like a crash course before you start your autumn session normally. And I think you might be able to do it in your autumn session too if you prolong your degree a little longer. And we also have UPass. So UPass is pretty much an extra class. Let's say you do maths and everything, you have your normal lecture and your tutorial, and then UPass is an extra voluntarily done class, and you can get help from students and everything that have done and excelled at this subject and everything.